find the definite integral of negative pi over 2 to pi over 2 of the function sine cubed of x times the cosine of x plus sine of x times the cosine of x dx. Okay, let's start. First I notice, aha, we have a symmetric interval of integration. It goes from negative a to positive a. So that means that we might be able to take a shortcut. Let's see if our function f of x is odd or even or neither. If it's neither, we can't take a shortcut. So f of x is equal to the sine cubed x times cosine x plus sine x cosine x. That means that if we evaluate this function at negative x, we get sine, just the sine of negative x quantity cubed times the cosine of negative x plus the sine of negative x times the cosine of negative x. But the sine of negative x is the same as negative sine of x, and that's going to be cubed times, well, the cosine of negative is just the cosine of x, etc., etc. Okay, so this is f of negative x equals negative sine cubed, since the third power of a negative is still a negative, cosine x minus sine x cosine x. So f of negative x turned out to be equal to the negative of f of x, and that implies that our original f is an odd function. So what does it mean? It means that if we graphed this thing from negative pi over 2 to pi over 2, we would get an opposite thing happening exactly on the left and right of the graph. So you can see we'd get a negative area added to a positive area of exactly the same quantity. That means the net area would have to be equal to 0. All right, in other words, we're applying the rule about odd functions. It says the integral on a symmetric interval of integration of the odd function is equal to 0. I love that rule.